In the cold, silent darkness beyond the moon's orbit, a golden mirror stares into eternity. The James Webb Space Telescope, humanity's most ambitious observatory, hangs suspended in the void, its giant sun shield stretched open like the wings of some cosmic moth, its segmented mirrors glowing faintly in the light of a distant sun. Webb is more than a machine. It is a time machine, reaching farther than any instrument before it. Where other telescopes saw stars and galaxies, Webb sees origins. The very first sparks of creation, so distant that their light has traveled for more than 13 billion years to reach us. Every photon that falls into Webb's mirrors is a whisper from the beginning of time. Every image, a story the universe has been waiting to tell. This is the chronicle of Webb's deepest discoveries yet. A journey into the dawn of galaxies, the birth of stars, and the mysterious worlds that orbit distant suns. When Webb opened its golden eyes for the first time, astronomers expected to see small, faint galaxies, tiny structures just beginning to take shape in a young universe. Instead, they found giants, massive, bright galaxies, appearing fully formed just a few 100 million years after the Big Bang. Galaxies so large, so structured, so unexpectedly mature that they defied the very models used to explain cosmic evolution. Their existence raises new questions. How did so much matter assemble so quickly? Did stars ignite faster than we ever imagined? Are our timelines of cosmic growth incomplete? Webb's deep field images revealed a universe far busier, faster, and more chaotic than we believed. In those ancient lights, captured across billions of years, lies a revelation. The early cosmos was not a quiet nursery. It was a crucible, violent, dense, and unimaginably bright. Within our own galaxy, Webb peered into the dark clouds of gas and dust where stars are born. Previous telescopes saw only shadows and silhouettes. Webb, with its infrared vision, sees through the dust, uncovering swirling nurseries lit by newborn suns. The Carina Nebula, once a mystery of opaque clouds, now glows with fiery ridges, pillars, and jets. There, young stars carve their surroundings with powerful winds, sculpting vast structures like cosmic cliffs and mountains. In one region, the cosmic cliffs, Webb captured stars in their first, fragile moments. Their light emerging from coils of gas that have existed since before Earth was formed. These star-forming regions are not peaceful cradles. They are turbulent storms where gravity competes with radiation, where clouds collapse into fiery cores that will one day shine across the galaxy. Webb reveals that the birth of a star is not gentle. It is an explosion of creation written in light and dust. Beyond our solar system, Webb is unraveling the secrets of exoplanets, worlds orbiting distant stars, each with its own climate, atmosphere, and potential for life. For the first time, Webb has detected the precise chemical fingerprints of alien skies: hydrogen, water vapor, methane, carbon dioxide. In some cases, hints of complex organic molecules, the building blocks of biology. On one planet, a scorching world of swirling clouds, Webb found signs of atmospheric storms larger than Earth itself. On another, colder and smaller, it detected gases that could indicate volcanic activity beneath icy crusts. The telescope has even begun to examine planets within their stars' habitable zones, probing for atmospheres that might resemble our own. We are witnessing the first chapter in a new era, the search for life not through speculation, but through spectral evidence. Webb is teaching us that the universe may be full of planets where chemistry plays the same delicate game that once unfolded on Earth. Webb sees in wavelengths no human eye will ever perceive. In the infrared, cold objects glow, dust becomes transparent, and ancient light emerges from the universe's long-vanished past. This ability allows Webb to look back to a time when the first atoms formed, when the universe was filled with a thick fog of hydrogen. As that fog slowly cleared, the first stars ignited, massive beacons that burned fast and bright, seeding space with the heavy elements that would one day form planets, oceans, and living worlds. Webb's images of these early epochs are not just pictures. They are windows into the cosmic childhood of everything we know. The telescope reveals galaxies colliding, clusters forming, and dark matter shaping the structure of space like an invisible hand. Each new deep field challenges our assumptions, showing a universe rich with complexity from its earliest moments. Perhaps the most mysterious discovery is Webb's glimpse of supermassive black holes in the infant universe. These monsters, millions to billions of times the mass of the Sun, appear shockingly early, far earlier than theories predicted they could form. Their gravitational pull organizes galaxies, accelerates star formation, and shapes the very architecture of the cosmos. Webb has now detected swirling disks of gas falling into these ancient black holes, their light redshifted across eons to reach us. How did these colossal engines of creation appear so soon after the Big Bang? What processes fueled their rapid growth? Are they relics of the first stars, or something older still? Each answer Webb provides seems to reveal a deeper mystery, a reminder that even now, the universe is filled with questions we have only begun to ask. Webb also gazes at the end of stellar life, the final breaths of suns that once shone brightly, now shedding their outer layers into space. The Southern Ring Nebula, a glowing shell of gas, was revealed by Webb in unprecedented detail. For the first time, we saw the binary companion at its center, a faint, dying star whose last exhalation sculpted the nebula around it. These dying stars are factories of heavy elements. The carbon in your cells, the oxygen you breathe, the calcium in your bones, were forged in the final moments of stars like these. Webb shows us that even in death, stars create beauty, casting the materials of life back into the galaxy, where they will one day become part of new worlds. At the heart of Webb's mission lies a profound question. How did the universe become what it is today? The telescope's deepest observations reach toward the cosmic dawn, the moment when darkness gave way to light. Each new galaxy Webb discovers is a chapter in that story. Some are small and chaotic, others surprisingly orderly, all of them racing to build the structures that will one day become clusters, superclusters, and filaments stretching across the cosmos. Webb is not just collecting images, it is assembling a timeline of existence, a sweeping history that traces our origins back to the first flickers of creation. Through its eyes, we see the universe not as a static expanse, but as a living, evolving masterpiece. Every discovery Webb makes forces astronomers to rethink what they know. The telescope has challenged models of galaxy formation, star birth, black hole growth, and even the timeline of cosmic evolution. Long-held theories are being rewritten. New ideas are being forged from Webb's data, ideas that may define astronomy for the next century. It is rare for a single scientific instrument to shift our understanding so dramatically. Hubble did it. The Large Hadron Collider did it. And now, Webb is doing it on a scale that dwarfs them both. Its observations are not just answers. They are catalysts for new questions, new theories, new ways of seeing the universe. The James Webb Space Telescope is humanity's latest message to the universe, a declaration that we are still searching, still curious, still driven to understand the cosmic story we belong to.